Okay everyone, welcome back to part 3 of this developer roadmap series where I'm going to finish the rest of this AI engineer roadmap. If you haven't seen the first 2 parts of this series, I go over all of these questions here. What is an AI engineer? Pre-trained models, OpenAI, API, embeddings, vector databases. And I think the last time we left off, we left off of OpenAI response API, but I think I also skipped this section here that talks about popular vector databases. Okay, so we're gonna start here. So vector databases, like I said in previous videos, when you are trying to train a model to do some kind of AI engineer use case, you have to store the data that you are training the model on, or if you're using to do predictions in some sort of database. And a popular use case of this is if you are using something like retrieval augmented generation, where you are pulling in additional information from an existing data source and using that to augment something that a large language model would say. Just to give you a clear example, if I had a question on what is the language model that is the highest on the language model arena right now, which is this leaderboard that ranks all the language models. The language model that I'm asking doesn't have that information embedded into its learning parameters. So it needs to grab information from an external source to tell me which of the language models is at the highest rank. All of that information from an exogenous source is coming from something known as a vector database. There are several vector databases that you can choose. They all do the same sort of things. The one that I'm the most familiar with that I use is Chroma. So I'll click on that, and then they have an official website. So they have cloud infrastructure that you can use for storing the vector embeddings to do your AI engineer use cases on. But I've mostly been using it as creating local databases within my projects. So I use this because it's super easy to use. All you need to do is install the package, and then you can create collections within your project, manage that database locally, and then you would store the embeddings there. And I use this because it's quick to use. I don't need to go through a bunch of hoops to use it. If you have a larger project and you need more infrastructure that your computer or server can't handle, you would use these other, or you would use the cloud infrastructure that Chroma has. But I have more experience with using Pinecone, which is a vector database that you can use their cloud infrastructure. And the differences between those is that you're not using any more computation for the servers that you are hosting your application on, and you're pushing it onto some sort of other server that you can just make calls to. The reason why you would want to use these vector databases as opposed to storing them within a directory of your project is that these vector databases come with some optimization techniques that makes it easy for you to grab information from them. Just to give you an example, say you have millions and millions of embeddings within a single vector database, and you might design something that's not efficient, so you might go through each and every index to find the actual embedding that you want, whereas you can use the functionalities that's built into these vector databases and it'll find that embedding much more quicker. Another popular vector database is Facebook AI Similarity search, and they use something known as fast nearest neighbor search. And nearest neighbor is another machine learning technique where, if you would imagine an embedding space, is basically if you were to represent your information within this plot, this 2-dimensional plot, it would be laid out like this, where things that are very similar to each other are close together, things that are very far apart have no similarities. This is just a simplified way of showing it. In reality, embedding spaces are much higher dimensional. This is showing 3 dimensions where everything has a X, Y, and Z axis, but you can't really show higher dimensional space. It's hard to visualize, but this is just a simple way of showing it. So the FAISS, the Facebook AI Similarity search, it has optimizations where you can find something that you are interested in, and then there optimization algorithms are able to find that much quicker by using nearest neighbor search. It'll plot your question on this embedding space and find what you're looking for much quicker. And then I'm assuming these other vector databases have their own special use cases for why you would want to choose them. So you can do your own research on that as well. I also noticed there's Supabase and MongoDB Atlas. So these are two widely known databases that are not so much used for vector databases. They're used for storing other types of data schemas. This looks like it's using Postgres, and then this MongoDB is a SQL database that I believe, no, this is a NoSQL, so it's just holding objects. Okay, so probably wouldn't advise you to use these two, only because I'm not too familiar with what their algorithms are using vector databases. It seems like these two, since they're also placed at the top, they're probably the most used for storing vectors. So I'll probably stick to these two. Implementing vector search. Indexing embeddings. This is a pretty important concept. If you're building any sort of AI system that uses large language models and you're using retrieval augmented generation and all of that, then understanding how you index your embeddings, how they are being retrieved, is very important. What this means is when you store vectors, your numerical representations, in a database, you need to store them in a way that's meaningful, and you store them according to what use case that you are using them in. For example, if you have all of these documents, you have pages and pages of, let's say, medical document, and then you're building it for a user, a patient that has questions about what kinds of diseases they have. If you're expecting the user to ask questions about diseases, it might be more efficient or optimal to store those embeddings, those medical documents, as the disease, because those embeddings for those diseases is what you can use to search for, to grab those documents in your database. If you had pages of medical documents and then you chunk them up by maybe paragraphs, it'll index them by paragraphs. It's going to be difficult for the model to find the embeddings or the information needed to answer the user's question, which is about diseases. But if the information is indexed by noise, that makes it difficult for the model to find information. Okay, and then this brings into the next question of how those embeddings are being retrieved. They go through a process of similarity search, which I've talked about in the previous video, which is basically using, I think most people use cosine similarity, which is, it's just a fancy formula for finding whether two embeddings are similar or not. You can probably just find the function, just find like cosine similarity between these two words or these two vectors. All right. Okay. Now we're gonna go into AI agent. Okay. So again, AI agent is anything that is autonomous, that can solve problems or carry out tasks. It also perceives the environment and makes decisions. NVIDIA also makes the definition or adds on to the definition that it needs to have some sort of memory mechanism. It's used for various types of use cases. I'm gonna click this. Agent use cases, click on top 15 use cases, and there's several high-end customer deliveries, personalized recommendations, market research and analysis, prompt voice search analysis. So AI agents is a pretty big topic in the AI community. If you were to be an AI engineer, there's so much you can do with using AI agents, but I don't want to overhype it because this can also be seen as a niche category. Not every company in the world wants to use AI agents. In my experience, they can also be very undeterministic, which can be a problem if you don't know what you're doing. A lot of the times when you're building these AI agents and they're interacting with clients, you would want them to be very accurate. There's always a human in the loop. Human in the loop basically means that there's still someone there that monitors the AI whenever it's trying to do something. And then there's React prompting. There was a paper written about it. It introduced, lovely authors, Yao, introduced this framework that improved the way that language models answer questions or improve their accuracy when they're giving their prediction. Basically, you would just tell the language model, this is also a prompt engineering technique, to think step by step about your answer. Provide some reasoning and generate your answer. And just simply saying think step by step, increase the accuracy of the language models, which it tells you a lot about how these language models are actually producing answers. And another thing that you can use is provide some logical examples that's telling the language model to make a prediction or to think about it before it's actually answering. An analogy of this is that if I were to ask you a question, calculate 57 times 42 or something, that's basically what you're telling the language model. You're telling it to just blurt out the answer without even thinking. But when you're telling it to think step by step, you're basically giving the language model a scratch paper for thinking out the problem before it starts answering. And yeah, so getting back to providing examples of thinking logically, it can also be helpful to provide those logical steps for the language model, showing it how it should think about the answer before it's even acting. So I think there is some examples here. Okay, so I think this is an example where if you were to ask a question about the Apple remote, the language model would produce some questions or a thought. I need to search Apple remote and find the program it was originally designed to interact with it. And then it does the search for Apple remote and comes back with an answer. So it's providing some thought and then performing an action. Once it has all the context that it's needed, it produces an answer. They have a whole AI agent roadmap, which I feel like I can talk a lot about. This is probably going to be in the next video. I know I was supposed to cover backend development, but I know more about AI agents because I've been studying a lot about them recently. I'll leave that for the next week's video, which comes out on Monday. Next on the list is Model Context Protocol. There was this huge shift in the way that computers communicate. The way that computers communicate over the internet is that there's some sort of standardized protocol that you need to define for the computers to talk to each other. In order for you to get data from another database, you would need to write custom code on your computer to interact with the API, the standardized protocol that they built for you. And the way that you would do that is that person would create some sort of documentation. You would have the two screens next to each other where you have your code and the documentation, and then you would be creating custom functions that interact with that database. That's the way things have been done traditionally. But this new way of trying to think about how we can utilize large language models is that they've created Model Context Protocol, which is a standardized way for AI agents to manage and share contextual information. So you can think of it like this. I built this language model, this AI agent, and then someone else had documentation ready. I could just tell my agent to go and read the documentation itself. It's able to grab all the information needed. And then when I have some sort of question on my laptop, I can just ask those questions and it can access all of these other APIs, all of these other data sources, and perform any action that I want. This is such a huge invention or a paradigm shift in how computers are going to be interacting with each other in the future. So for example, there might be someday where people have their own AI agents and they're just talking to other AI agents, grabbing information that is needed, and it'll make development or grabbing information very different. It might also eliminate the need for someone to manually create custom functions for interacting with other APIs. The way people accomplish this is through creating a server-client architecture where some people can host their own standardized way of letting other clients know they have data available, and these clients would be communicating with all of those hosts and grabbing information whenever they need it. There's also data layer and transport layer here, which I don't think is too relevant for what is needed to know about Model Context Protocol, but yeah, it's just a way for AI agents to communicate over the internet. Next, we're gonna move down to multimodal AI. A modality is just a different way of interacting with a language model. And then all those different modalities, you can combine the modalities to make a multiplicative effect. The model can understand more context into what you are trying to do or what it's trying to understand. So imagine I just gave a language model text, and I said I'm having an issue on my computer and the language model doesn't have enough context to solve the problem for you. But if I could upload an image and I said, here's an image of whatever problem that I'm having, can you fix it for me? And the language model has more modalities to understand what you are encountering and can better solve the problems you have. There's image understanding, image generation, video understanding, audio processing, text to speech, so making the AI talk to you, and then there's speech to text, which is just transcribing the text from speech. I feel like you can specialize in each of these cases. I'm probably in the boat of just textual understanding, and I have some knowledge into each of these areas, but like something like audio processing, which I've studied a little bit for my PhD dissertation. There's several different features that you can embed into a language model to improve the understanding of audio. People have experimented with creating spectrograms of audio and having the model make predictions on images. The fundamental way of getting an AI model to understand what it is you're looking for is that to transform each of these modalities into some numerical representation. The way you transform those modalities into a numerical representation, you need to have some sort of knowledge in that area in order for you to make those decisions. Like something like audio processing, there's several different features that you can use in order to numerically represent audio. You could use pitch, you could use volume, you could use the spaces between text, you could use the speech disfluencies in a user's voice, where if they're saying or like a lot. In order for you to create or optimize the meaning of those features, you need to know what those features mean. Each of these other modalities have their own special features that you need to understand. So yeah, that's my take on each of these multimodality AIs. Okay, development tools. So this is a huge one. Development tools. I'm a big fan of AI code editors. So I use Cursor and Windsurf. I've used that a lot in the past. I've also had a video on this channel comparing the two AI editors. You can go check that out. I know there's also a new AI editor called Anti-Gravity made by Google, and it's also free for now. I don't know how long this is gonna last, but if you want to check it out, I'd highly recommend you take a look at it. You have access to the Gemini 3 Pro models and the other higher end models. I think Opus 4.5 is on the top leaderboard for web development. You have free access to those. And then there's these other companies or software websites that are trying to make AI editors. There's also Figma, that is a brainstorming collaborative board, mostly used by UI and UX front-end engineers to prototype something quickly to show people, hey, this is how the front end is going to look like. There's a lot of different software companies that are trying to build AI code editors nowadays. And then code completion tools, I've used this. I was against this. It's funny because I use AI code editors a lot now, but when GitHub Copilot came out where it was completing my code, I didn't really like it because the code that it produced was a bit distracting for me. Whenever you'd be typing, try to autocomplete and predict what the next code you're trying to write, and most of the time I got things wrong. But yeah, so that's my take on development tools. And moving on to implementing modality AI, these are popular APIs that you can use to utilize these different modalities. OpenAI Vision API, they have a very good Sora, I believe. Sora 2, if you haven't checked it out, is really good at producing videos. Is that what this is showing here? Okay, so maybe that's not what it's showing, but I know that Sora is a pretty good model for OpenAI. There's also Dolly API. This is also made by OpenAI. There's also Midjourney. I know people have had more success with Midjourney, so that might be something you would want to check out. Whisper API is a speech recognition API made by OpenAI, and this is free to use. When you're trying to build an application that's doing speech recognition, you can just use this and it's freely able to be used. And of course, like I said in previous videos, you can also use models from Hugging Face, LangChain, and Llama Index. These two are frameworks that are used for building AI workflows and AI agents. So we've completed the AI engineer roadmap. Thank you all for watching. In the next video, I'm going to be covering the AI agents roadmap. Stay tuned for that. If you want to be on top of that and see when that next video comes out, then please subscribe, like the video, comment down below. If you tell me what problem that you're trying to solve that incorporates some sort of AI agent or trying to be an AI engineer, I genuinely like to know like the users that are watching this channel. So if you guys comment down below, I'll most likely comment back and try to talk to you guys. And yeah, thanks for watching. See you guys in the next video.